many features in a circle. Example, any line that divides a circle into two equal parts, the name of that line is called diameter. Okay? And any line from center of, I hope you can hear me very well.
Yes, sir.
And any line that moves from center of a circle to any point on the circumference, the name of that line is called radius. Now, when you have two lines drawn in a circle, and that two lines are radii, radii is plural of radius. Okay, so if I have two radii, that means radius into two. Then it normally makes for us what we call sector. Sector. Okay? That means a sector looks like this. If I give you something that looks like this, one, then another line, two. So this is radius. This one also is radius. Here is the center. And then this is an arc. All right? So we call this sector. Is that okay?
Yes, sir.
It will always come with an angle at the center. That is why we say every sector subtends an angle at the center. So in this case, theta is the angle. Now, when that diameter is drawn in a circle, one side of that circle is called semicircle. Semicircle. All these things that I'm saying now shall be used in circle theory. So it is very important that we understand the organigram of a circle, the features of a circle, the entire terms that are used in circles, because they shall contribute to explaining theorems about circle geometry. Now, semicircle is half of a circle. Now, between 2 points on a circumference, we call that an arc. In other words, this place now is called an arc. So if here is A and here is B, so I have something that is called arc AB, arc AB, arc AB. Okay? So that arc AB, let me write it the way it can make more sense. From A to B is an arc. I wish to use a different color and put it here. So here is an arc. Yes, it's better. So you can see I have used a different color to identify the arc. Okay? That is an arc. Then again, if there is a line that divides a circle into two unequal parts, like in this one, I prefer to use a different color for you. So let's say I use this one now. This is called a chord. A chord. And what is a chord? A line that divides a circle into two unequal parts. What that means is that if I give you a circle now and I draw a chord, now that chord does two things in a circle. It creates what we call major segment, and the minor segment, and the minor segment. So what is a segment? A segment is a part of a circle formed by a chord. A chord is a straight line passing through a circle, but not from the center. Not from the center. Once it is from the center, the line no longer becomes chord, but it is now called a diameter. So this is a chord here. Now that chord makes two shapes. One is called major segment. The other one is called minor segment. Okay, moving forward, even in this chord now, from A to B, the arc there is still an arc. Okay, it is still an arc. We also use all these things in geometry, not only in mensuration, not only in geometry. Now, let me summarize what I have done so far. I've told you that in a circle we have semicircle. I've told you in a circle we have radius. I have also told you that in a circle there is an arc. I've told you that in a circle there is a angle subtended at the center. I've told you that in a circle there is what we call a sector. And I have also told you that in a circle there is a chord. Then every circle has a center. And the center of every circle is normally denoted with the letter O. So, and sometimes it comes with a line crossing the diameter, e.g., if I draw this one now and put this line, that is a sign that that line is passing at the center. And then with the letter O, that is how to indicate center of a circle. Now, that place is always seen as the origin. Like if you are doing geography, the spherical nature of the earth always emanates from the center of the earth's surface. But let us not go there. So therefore, understanding these basic terms, what are the terms? Chord, diameter, radius, sector, arc, center, segment, semicircle is very important. Did you hear me?
Yes, sir.
All right. So with this now in mind, we can now propound the first theory in circle geometry. If I give you a circle like this, and in this circle, there is center, and there is an angle formed at that center, then the 2 points that form the angle at the center is also used to form another angle at the circumference. Very beautiful. Sorry. This is a straight line, please. So now, let's say that this place is called X, or 2X rather. Then this place is called X. What does this thing mean? It means that the angle at center is twice the angle at the circumference. We say an angle subtended at the center of a circle is twice the angle at the remaining part of the circle. Okay, very beautiful. What does it mean? We will begin to see so many questions that can be solved using this theory. It is very important. Remember, I mentioned it, theorems in a circle. Anytime you see that 1 point on the circumference or 2 points on the circumference, we are used to form an angle at the center. The same 2 points, we are also used to form an angle at the circumference. Please, there is something I forgot to tell you on that characteristics. That line covering the circle is called the circumference of a circle. Very important, because we shall also use it. So it's part of the terms. So this one is already clustered, so I have to put it here. Distance around any circle is known as a circumference. Therefore, anytime 2 points form an angle on the circumference, and the same 2 points form an angle at the center, we will conclude that the angle at the circumference multiplied by 2 is equal to the angle at the center. Do you understand?
Yes, sir.
What that means is that if I give you this circle now, this is a circle, and I have formed an angle at the center like this, then I formed also an angle at the circumference. Please, this should be a straight line. So when I draw it, understand it is a straight line. Now, and I told you that this place is 230 degrees. And I put here letter Y. And you are asked, what is the value of Y? What do you think will be the value of Y here now?
You would do 360 minus 230.
You are going to do 230 divided by 2, which is equal to 115 degrees. So the angle at the circumference is 115 degrees. Why? Because the one on the circumference times 2 is equal to the one at the center. Now, look at what I wrote here. This is my theory. Angle at the center, angle subtended at the center. Get this. Angle at the center of any circle is twice, get this one now, is twice the angle at the remaining part of the circumference. So see the circumference, y. So when you multiply y by 2, you get the center. When you divide the center by 2, you get the circumference. Is that okay?
Yes, sir. What does subtended mean?
Subtended means formed
Oh,
at
okay.
the center. 3a. The first one. You can see there, the angle at center is what? 138. Can you see that?
Yes, sir.
Now, and I am asked to find the value of x. The value of x is going to be 138 divided by 2. And what is the reason? The reason is just that is a language I have stated for you. That place I stated a theorem. And I say the angle at center is twice the one on the circumference. That is the reason. So what it means is that 2 can divide 13 to give me 6, remainder 1, and 2 into 18 is 9. So that is 69. Therefore, the value of x here is 69. What does that mean? It means at this place you can see x, the angle there is 69. When you multiply that one on the circumference by 2, you get the center, and the center should be 69 times 2, which is 138. In number 3b, they gave us the center as letter x. Why the circumference is 45? What do? You are simply going to say that x is equal to 2 multiplied by 45. Why am I doing it? Because I know the theorem. So, and that is going to give me 90. What is my reason? Angle at center equal to 2 times what? Twice the circumference. So this is my reason. That is an abbreviation, CIR, means circumference of a circle. Is it okay?
Yes, sir.
So if I multiply the circumference by 2, I get the center. That is why the value of x here is 90 degrees. Let's go to question number 3C. I am asked to find x, but it's still the same thing. How do I get x? X is equal to 127 divided by 2, which is going to give me 63.5 degrees. Answer. Why? The center divided by 2 is equal to the circumference. The circumference multiplied by 2 is equal to center. Okay? Now, 3D, I am given to find the angle at center, which is letter x. And that is going to be 50.5 multiplied by 2. Okay? And that is going to give me 101 degrees. So that is the angle that should be at the center. In other words, here is going to be 90 degrees. Here will be 63.5 degrees. And here is going to be 101 degrees. Ask me a question before I move to the 3B section, section B.
I don't have any questions.
You understood what I'm doing now on my application to it, right?
Yes, sir.
Cool. Remember, I just stated only one theory, and we are trying to sample out questions on it. Okay, that is what I'm doing. There are many questions that can come under circle, but only one theory is what I am explaining. And in that one theory, so many circles are drawn for us to use it to interpret them. Now, let's go to the B part. And the question has asked me to find ACB. Look at it, ACB. Normally, the angle is the one at the center. That is it. The center letter is what you are looking for. If I give you now something like something like this, if I give you x, y, z, it means I am asking you to find the angle at the position of letter z. Do you understand?
Yes, sir.
Okay. So therefore, ACB here is simply asking me to find the angle at the C. ACB, that space there, I should find the angle there. If I may ask you, based on what we did in section A of this number 3, what would you say should be the angle there?
The angle is 150.
Okay, 150. And I will tell you that it is not correct. You may be wondering why. It is not correct. You know why?
Why?
The reason is because that 300 is not here. Watch out. It's not here. So it is the angle here that you will use to determine this one. So you are going to do 300 minus 360, section B. I want to change the color. Section B. Just follow me gradually. Section B. Now, in this section B, I don't want to scroll out to our image. I will do 360 minus 300 equal to 60. I will tell you the reason. So it means that here is angle 60. Is that okay?
Yes, sir.
Therefore, that angle they asked me to find, ACB, is going to be 60 divided by 2, which is equal to 30. So the angle here is 30 degrees. Now, let's go back to the one I have done before so that you now get the reason more. You will notice that, see the 2 points, A, follow me, A and B, formed angle D at the center. Is it not true?
Yes.
So that point that form the angle, you see that the angle is facing the arc AB. The angle facing the arc AB is what you use in getting the one on the circumference. Pure. Let's go back to the one I did earlier. Watch out. See this place. This point and this point, we are used to form angle 138. Can you see the 138? The 138 is not inside that quadrilateral. Can you see? It's not inside. It is outside. Therefore, that one that formed at the center, outside the main image, is what gives me the one at the circumference. Watch out here. See where X is in B. I am in B now. See where X is. Is X here? Is it here?
No.
Therefore, that is the secret on knowing how it works. So the 2 points that form this X is here and here. So 2 of them we are drawn to the center here to make this point called letter X. Therefore, that X divided by 2 is equal to this 45. And this 45 multiplied by 2 is equal to this X. Now you can now see the reason why that 300 shouldn't be used to find the angle at circumference, because 300 is inside the four-sided shape. Why? Look at it. See where the 300 is. So I now subtracted 300 from 360 to know the one that should be this place that is red. And that is 60. That 60 is the one I will divide to know the angle at C. Now, the question should be, why did I subtract from 360? Do you know why? Angle
No.
at a point. Angle at a point is equals to 360 degrees. What does it mean? At any point in a circle, the angle there will sum up to 360. Look at what I mean. If I give you this point now, the angle here is 360. If I draw a line like this now, 1, and draw a line like this, 2, and I tell you that here is 60, it means that this side is going to be 360 minus 60, which is equal to 300. Is that okay?
Yes, sir.
So any point inside a circle has an angle of 360 in total. Take note of that. If I come to this point now, this dot, and I draw a line like this, straight, and I come to it, So it means that this side is 180. This side also is 180. Are you following me?
Yes, sir.
We call it angle on a straight line. Angle on a straight line. You must have heard about it. Is always equal to 180. So if this is a straight line, it is 180. This side also straight line, it is 180. So round it is 360. Does it make sense?
Yes, sir.
Now, going back to the question I just answered, let's come back to it. So look at it, the one they gave us here, 300, isn't it?
Yes, sir.
It is on that center. So if you subtract 300, the other inside will be 60. And that 60 is what I will use to determine the angle ACB. And what do I need to do? I will divide the center by 2 to get the circumference, because when this place now is 30, if you times it by 2, you get the center, which is 60. Ask me a question before we move on.
So what you just said, can you just like summarize it so I can write it down in my book?
Okay. Summarizing it, I have said a lot of things, so including giving you because these are questions actually. So let me summarize this way. The first theory I have given to you is a theory that says that a angle at center is twice the angle at the circumference, and I wrote it down for you. It is here. It is here. Okay, I have passed it. So, okay, the first thing I said, let me start from there, is that I gave you the main keywords that are used in circle geometry. Those things I said, you should know their meaning. One, you should know the meaning of diameter, the meaning of radius, the meaning of semicircle, the meaning of center of a circle, the meaning of arc in a circle, the meaning of sector in a circle, the meaning of segment in a circle, the meaning of diameter in a circle, the meaning of chord in a circle. So these were the first things I said, giving you the terms that are used in circles. Now, the second thing I said is that I went into the theory of a circle, and I started with the first theory. And that first theory that I started with is that the angle at center is twice the one on the circumference. I wrote it down for you. Look at it. And I applied it with a drawing. So I gave you a diagram. In fact, this diagram that is here is very important. This particular one you are seeing. This one here with an arrow. It is very important. It is the explanation of this grammar, this theory that I have stated, that once you are looking for an angle at center, if you are given the one on the circumference, times it by 2, you get the center. So 2x means the circumference times 2, because the circumference is x. Times it by 2, you get the center. And the reverse is the case. When I give you the center, divide by 2 so that you get the circumference. So this is the second thing I said in that category. Angle at center is twice the one on the circumference. Now, still on summarizing for you everything I have said so far. Then I gave you application, the 3A part of how we can use that theory that I have stated. And what is that theory? Angle at center twice the one on the circumference. And I have solved these 1, 2, 3, 4 questions, applying that one theory, finding the center angles and the circumference angles. That is the second thing. The third is now. This place I started now showing you that sometimes, because it is intellectual work, that questions can flip in different forms. That the angles now has moved from being at the right position as in this A part to being in the opposite side, as in this case 300 for section B, number 1. And I told you, you cannot use 300 to determine this angle at circumference, but rather you have to subtract 300 from 360. That is where I gave you another important theory, meaning I have given another theory now called theorem 2. and that is this point. This point now can be theorem 2. Okay, theorem 2. And what does it say? That the angle at a point is equal to 360. That is one of those things you say I should summarize. But I chose to start from the beginning. Angle at a point. I demonstrated what I mean by a point to you. If you look at these circles, they always indicate point at the center. Okay? That center, the angle around it is 360. So that is the second thing I gave you. Meaning, I have given you theorem 2. Now, the third one I said in the line of summarizing so far is angle at a straight line or on a straight line is equal to 180. This can be theorem 3 now. Okay? What does it say? Angle on a straight line is always equal to 180. Angle on a straight line is equal to 180. That is another thing worthy of giving you as a theory or in the summary, saying, explaining it further. It means now if I draw this line here and I draw an angle here for you, and I say that this place is 43, and I ask you what is this place called X, the first thing that will come to your mind is that this line is a straight line. And every angle on a straight line, you are told in theorem 3 here that it is always equal to 180. What do? You write x plus 43 should always be equal to 180. Why? X and 43 are on a straight line. Remember, I drew this line before for you, and I called it a straight line. It can be drawn in any form. And I say on this straight line, this side is 180. This side also is 180. And the two of them met together is 360. That is what I said earlier. Therefore, on this side that is 180, I have said that the x plus 43 is equal to 180, meaning that x is 180 subtract 43. So that is what will give you the actual value of that angle, labeled letter x, which is going to be equal to 137 degrees. Can you see the reason why we said angles on a straight line? Angles on a straight line, you can put it in plural. Angles on a straight line will always be equal to 180. It's very important to you. I think that is the summary. Are you getting it?
Yes, sir.
Okay. So, but meanwhile, just put the ones you can put down on your notes. Subsequently, as I usually do, I will send you the lesson note of today's session, okay? So that anything you skip, you can gently go through them and then write them down very well. Now, going back to the examples on that particular image, look at this question number 2. Are you there?
Yes, sir.
In this question number 2, I want to find the angle here, and it is called AEC. AEC, where is E? The reference angle, AEC, where is E? E, A, B, C. Okay, let me clean this place. Oh, I have seen it very well. So that center is called letter E. Is it okay?
Yes, sir.
Now, if they say AEC, look at A, look at E, and look at C. Look at where they are asking you to find. Does it make sense?
Yes, sir.
What will be the answer? I'm asking you.
You have to do 62 times 2.
So what would they be? 124. So what you said is what you will do. It's correct. Angled at a circumference times 2 is the center. Is it not what we agreed?
Yes, sir.
So that's what you said is correct. Now, watch again in number 3 of DE is equal to 113. And I just explained to you now that angle on a straight line is equal to what? And
180 degrees.
180. Now, Itunu, see with me that this line called line E D C is a straight line. Line E D C is a straight line. Do you agree?
Yes, sir.
If it is a straight line and I ask you, what is the angle ADC? Look at the place. Look at it here. ADC. Look at ADC. So I'm asking you for this angle. And from ADE, it is straight. It means that 113 plus ADC, 113 plus ADC will be equal to 180. Will be equal to 180. Okay? And my reason is because it is on a straight line. Angle on straight line. That is my reason. Okay? Line EDC is a straight line. Therefore, if I plus the angle 113 plus the angle ADC, two of them must be 180 because we have agreed that any straight line must have angle on one side 180. So if they have told me that this one now is 113, which means here is A, here is D, and here is E. And I'm asking you A, D, C. Look at C. So I'm asking you this side. What that means is subtract 113 from 180 and your answer will come out. So I will now come to this place. I'm right. A, D, C, as I asked you, will be 180 minus 113. And that is going to make my answer 67 degrees. So the question I was asking you when I said, what value, what angle is the angle ADC? Is simply this 67 here. That is what I wanted you to say. Sorry, I want to make it clean so that you can easily see very well. Okay, beautiful. So I was asking you for this angle I wrote down. That place now is called ADC. Another name for that place is called angle at circumference. Why is it called angle at circumference? Because it is on the circumference of the circle. I don't know if you get me now.
Yes, sir.
And without knowing it, without knowing that that place is 67, you cannot answer this question here. This question here. They say find angle ABC. Find this place. That is what they said. So it is when I know this ADC, that is when I will know here. How do I go about it? I will now multiply 67 by 2 to get that place they called ABC, which is the main question that I was asked to find. So in conclusion, what they gave us to solve is ABC. We can now say therefore, A, B, C is equal to 2 multiplied by 67. 2 multiplied by 67. 2 multiplied by 7 is 14. 2 multiplied by 6 is 12 plus 1, 13. And therefore, that answer is 134. And it is obtuse angle. They told us that that angle is obtuse angle. What is the meaning of obtuse angle? The angle that is more than 90 degrees and less than 180. In fact, angle between 90 and 180 is called an obtuse angle. They told us, find the obtuse angle ABC. So, what we will write here now is 134 degrees. Mind you, they did not give us the angle at circumference. What they gave us is the angle outside. So we as 113. Therefore, we now use that angle outside to find the one in the inside. Okay? And when we got the inside, we multiply it by 2 to get the actual question that was given to us in this number 3. And how did I get 67? I saw that this line CDE is a straight line. I applied angle on a straight line to finding the circumference angle. Please tell me if you have understood me on that part. Because I know sometimes it can be tricky. But if you are meticulous and focused, you'll be understanding the tricks. The tricks as far as circle geometry is concerned. You must understand theory very well, and then you apply it. What do I mean by theory? I have already given you 3. There are many, but I've just given you 3. I've given you angle on a straight line, that any straight line you see, if you plus all the angles on it, it will always give you 180. That any point in geometry, if you plus all angles round it, it will always be 360. That any angle at the center divided by 2 is equal to the circumference. And any angle on circumference multiplied by 2 is always equal to the center. Angle at center twice the circumference. These are the 3 theories that I have stated already. There are many more, but we'll be taking them one after the other. That is the way it should be going. So, ask me questions.
I don't have any questions. I understand it now.
Okay, beautiful. So, I will allow you to maybe put 1 or 2 things down. Meanwhile, I sought out for more questions for practicing, because as we bring questions, solving them, using them to explain, that way we'll be getting to understand the application of the theorems. The application of the theories. So, put anything you want to put down so that we move on. So, 6 questions here. Let's look at these 6 questions. If you look at them, okay, there are some you can answer. There are some you cannot answer. When we come to those ones you cannot answer, I will tell you a theorem you must know, MUST, that can always help you to answer them. And without knowing those theorems, you cannot answer them. Therefore, from the first one, we are looking for letter X, the angle at X. What do you think should be the answer based on our so far steps taken? What do you think?
You have to do
Excellent.
160.
Excellent. You have already gotten the answer. So what is the value when you have it? That is the
degrees.
answer. So you can see knowing the theory is almost the ultimate. You understand? Ordinarily, if someone doesn't know the theory and you tell the person what is angle X, he might solve for the next 30 minutes and he getting nothing. But you have not solved anything. You just look at it and you know the answer. Is it not true?
Yes,
So
sir.
it is driven by knowing the theories. And again, GCSE will always tell you, give reasons. Give reasons. So in this type of question now, if you tell them X is 60, they will tell you give reason. You're right. Angle at center twice the circumference. Do you understand? Angle at center. Angle at center twice the circumference. The circumference. Do you get me?
Yes, sir.
So when you hear reason or you see reason in that GCS equation, you see angle at a center, angle at center. So if you see something like that, it means state this theory. That is the meaning. Now, what do you think is the answer to the second one? So this one is correct. Second one,
112
it's as simple
degrees.
as that. X is equal to 2 multiplied by 56. 2 into 6 is a 12. 2 into 5 is 10 plus 1. That is a 11. 112 degrees. That is the answer. Anywhere you go. Once you play, you key in this 112, your answer comes out. As simple as that. Or the system checks it correct for you. All right. Now, for this one, I will tell you a theory that can solve this type of question. It is not this one that answered these first two. Okay? Now, let me go to another theory. Are you with me?
Yes, sir.
So a theory says that angles in the same segment. So I will call this one theorem 4. I've already given you theorem 4. And I write angles in the same segment. Angles in the same segment. Can you now see the reason why I started giving you the meaning of all those things before? You are hearing their names now. In the same segment. If you never heard of segment, you will not understand what this thing means. Angles in the same segment are equal. And I will explain further with a diagram before we come back to this. Okay? So now look at this. If I draw a circle like this for you, if I draw a circle like this, good. And I draw from this place, look at what I have drawn. Watch out. This place can be taken to be A. Just let's call this place A, X, and call this place Y. Did you hear me?
Yes, sir.
I have made an angle here already. This place is an angle. Are you aware?
Yes.
Now, I use the same X and Y and form another angle. The same X and Y, not another place. I'm using the same points for X and Y, and I have formed another angle here. So I can call this place A and call here B. Okay, and that is what we are saying. Because the same point X and the Y, we are used to form angle at circumference A and B. Their answers will be equal. If A is equal to 30, B also will be equal to 30. Is that okay?
Yes.
So we call that angles in the same segment. Very important. It is also a theory. So I have given you 4 theorems today so far. Okay? Angles in the same segment are equal. Watch out now. Ituno. Watch out. See this point. Can you see the point they created here? Can you see another point they created here? Can you see the 2 points?
Yes.
2 of them were used. They used the 2 points to form this angle 44. They used the same 2 points to form this angle X. Conclusion. Answer. X is equal to 44. Chicken, huh? You did not solve anything. The only thing that told you the answer is knowing the theory. Do you get my explanation now?
Yes, sir.
So maybe you want to put something down, you can do. Angles in the same segment. We have explained the first 3 in the first row. And the first 2, we used angle at center twice the circumference. The third one, we use angles in the same segment. The same segment. What is a segment? A segment is formed by a chord. Let me show you the segment in this drawing now that we have just done. This is my drawing. If you want to see the segment on it, see the segment here. Watch out. See X and Y. If I draw a line here, if I draw a straight line here, can you see that straight line? The name of that line is a chord. Are you aware?
Yes, sir.
Because every line that touches the circumference of a circle, once that line is not passing at the center, the name is chord. Now, that chord was used to form angle A on the circumference. The same chord was used to form angle B at the circumference. That is why we say they are in the same segment. Can't you see that A and B are both in the major segment? Why what was used to form them is the minor segment? Which chord? The chord that created the major segment and the minor segment is what we use each end to form angle A and angle B on the circumference. So that is when we apply angles in the same segment. All right. Let's go to the fourth question in this table. The fourth question. Should I go ahead?
Yes, sir.
If you look at this, watch out this point. You can see my cursor. Watch out this point. Watch out another one here. If you like, this is a chord. It is not passing at the center. Is it not true? The chord has made two segments. This is a minor segment. This is a major segment. Okay? So, do MS. Minor segment, major segment. The chord, the end of the chord that form the two segments, we are used to form angle what? 67 here. And they also formed angle X. You conclude X is equal to 67 degrees. If you Q it now in the system, it will give you accurate answer. If the question has said, give your answer with reason, what do you write? Angles in the same segment are equal. That is all. You write for them, angles in the same segment are equal. So you can also add it to your note that you haven't drawn this circle and you have also written down your answer. Let them know or put down the reason why you know that 67 is equal to X by writing. You can decide to put it in bracket or you just state it beside it. Angles in the same segment are equal. In an exam, if they ask you this question, they will just write one word that means a lot. They will write give reason. Give reason. That is all. And what is the reason? This. Why did they ask you to give reason? It has its own mark. Without a reason, you don't end the whole mark. If this question now is a GCSE question, and the question has asked you to find X with reason, it may be 2 marks. Okay? In that 2 marks, getting the answer is 1 mark. Getting the meaning, the reason is 1 mark. So when you give them the answer with that question, no value is given. Is it true?
Yes, sir.
No value is given is because there is a theory that will unlock the answer. Without you knowing the theory, you will be wondering that they made a mistake in this question because in the previous ones, they have been giving you values. They will put angle at one corner and ask you to find. But this one, it is theory that will unlock it. Therefore, I give you theorem 5. I have given you 4 theorems today already, isn't it?
Yes, sir.
Okay, so I am giving you now the 5th one, the 5th theory in circle. And here is it. Angle in a diameter, angle in a semicircle is a right angle. Theorem, I want to use a different color. Theorem 4, theorem 5, under circle geometry. Angles in angle in a semicircle. You can see semicircle is mentioned. One of the terms that came out when we were explaining circle is a right angle. And what is the meaning of right angle? Right angle means 90 degrees, angle 90. How do I know? Let me give you an image, a diagram that explains the theory. I told you earlier when I drew a circle. In that place, I told you, any line that divides a circle equally, or a line that passes from center of a circle, the name of that line is called a diameter. If that diameter is used to form an angle on the circumference, that is, the 2 ends of the diameter is used to form an angle in a semicircle, the name of that angle formed is called angle 90, right angle. Can you see it now?
Yes, sir.
So what you'll be looking out for is that anytime you see a circle and there is the line at the center of the circle, and the line at the center of the circle, the 2 ends of it, or that line is a diameter, and the two ends of that diameter is used to form an angle on the circumference, just conclude immediately without wasting time that that angle formed there is angle 90. Is he okay?
Yes, sir.
So therefore, with this information, I will take you back to that question where no value is given. You can now see this is a diameter. They told us, look at the point at the center. Look at letter O, indicating that that line is a diameter. And the two ends of the diameter form the angle X at the circumference here. In conclusion, X is equal to 90 degrees. Chicken, as simple as that. Do you understand it now?
Yes, sir.
So I have given you 5 theorems tonight. And what I will call it, angles. The opposite angle. The opposite angles of a cyclic quadrilateral are supplementary. Okay? I hope you can understand this root word as supplementary. Okay? What does it mean? They sum up to 180 degrees. I don't know. So I will draw. Let me draw now. If I draw a circle for you, and in that circle, there is a shape drawn inside it, and that figure is four-sided. Look at it. It is four-sided. Okay? So that means it has 4 angles. And the 4 angles touches the circumference of circle. Remember I told you earlier at the beginning, I told you these root words will always continue to come. Now, the 4 angles, let's say here is angle A, B, C, and D. Are you seeing my board?
Yes, sir.
Now, opposite angles are sum up to 180. It means that angle at A plus angle at C will be equal to 180. So I can write for you DAB is equal to DCB. Sorry, not equal to. Plus DCB is equal to 180. Now, what is the meaning of supplementary? Supplementary means when you add 2 angles and you get 180. Did you hear me?
Yes, sir.
When you add 2 angles and you get 180, the angles are called supplementary angle. What is the meaning of cyclic? Cyclic quadrilateral means a 4-sided figure that is inside a circle. So because it's inside a circle, that is why it is called cyclic, meaning inscribed in a circle. And it's not only that it is inside a circle, it is 4-angled. It is 4-sided. That is why you hear quadrilateral. Quad, the word quad, Q-U-A-D, means 4. So when you see 4 angles, 4-angled shape, drawn inside a circle, and the 4 angles touches the circumference of the circle, the two opposite must be equal to 180. And that is what we call opposite angles of a cyclic quadrilateral are supplementary. Sum up to 180. Supplementary. The two opposite are supplementary. Now, moving forward. Again, look at this part. Look at this place now. And this place. So I call it angle ADC plus angle ABC will be equal to 180. Two of them are opposite. Do you understand?
Yes, sir.
Beautiful. So, this is the explanation to this theorem 6. That once you see a 4-sided figure drawn inside a circle, whereby the 4 angles of that shape touches the circumference of the circle, the two opposite angles must be equal to 180. In conclusion, we go back to that question that led to this theorem. I have stated 6 theorems now. So, Let's go back to it. You can now see that without you wasting time, you'll be able to say for me the answer for x. Don't you think so? The angle here plus the angle here are opposite. Is it not true? Why? Look at this place. 1, 2, 3, 4. The 4 angles are touching the circumference of the circle. And the shape inside is 4-sided, having 4 angles. The two that are opposite to each other must be 180. In conclusion, the value of x here must be 180 minus 80, which is 100 degrees. So the value of x is 100 degrees. Is it okay?
Yes, sir.
Yeah. You have a question you ask?
No, sir.
You don't have?
No, I actually understand this theorem because I feel like it's quite easy.
Okay. Beautiful, beautiful. You understood the one that says angle in a semicircle is a right angle, isn't it?
Yes, sir.
You also understood that the one at the center is twice the one on the circumference.
Yes, sir.
You also understood that angles in the same segment are always equal.
Yes, sir.
You understood that angles on a straight line will always sum to 180.
Yes, sir.
And you agree with me that every angle at a point will always sum to 360.
Yes, sir.
Okay, so we have finished these 6 questions now. So I come up with more questions.
na mbụ agwara m mmadụ si